Hello everybody, this is Cameron Snow with Danomics.com. In this video, I'm going to demonstrate how you can make 3D property models in Danomics, similar to the ones shown here uh, in the platform. Alright, so let's get started. So before we can make a 3D property model, there are a few things that we need to have available to us. First of all, we need to have the interpreted petrophysical properties. So I've gone through and I've made my petrophysical interpretation, and I've done a full interpretation here, and we're ready to go on that front. Um, Other things that I have done here is I have came through and I've picked all my tops. So we've looked at this here in cross-section view. I've picked out all my tops, and then I ran this structure gridding flow. And this flow, if you've not done this before, you can go check out the video that we released on making structure grids. But essentially, we bring in our tops. We can optionally filter down to the tops of interest. We can take our deviations into account to put those into TVD space. We can do some optional filtering of like outlier data using our spatial filtering tool. Then we use the new tops to structure gridding tool, which uses that new constrained Kriging algorithm to generate a robust structural model. We can apply some optional smoothing to that if we'd like, and then we can write out the grids. Once we have done that, we I would recommend that we also generate the petrophysical curves. We could generate these live as part of the modeling flow, but I think it's more efficient to generate them ahead of time. So what we do is we bring in our logs, we determine what properties we'd like to calculate based on our petrophysical interpretation, and then we write those out to a log database. In this case, it's this database called petroresults.ldb. Now, what we're going to do now is we are going to write a flow that will generate this model. And what I'm going to do here is I'm going to start from scratch. So I'm going to remove this flow here. And so what we do to generate this volume is we say new flow, and I'm going to make a flow for the maturity. So I'm choosing this. I'm just going to name this maturity model.flow. And there's only three tools that we need to add here. We need to add a log input, and we're going to choose this Petro results LDB that we wrote here. We're then going to use log to volume. And at the time of recording this video, this log to volume tool is still in the beta phase, so to say. So there may be some changes to it as we get some user feedback and do a little more testing on it, but it'll largely be similar to what you're seeing here. So I'm going to choose my structure grids here, and what we need to do is we need to say what zones we want to use. So I want to essentially use most of these zones. I'm going to use, my Lewis, Teapot, Parkman, Sussex, Shannon, Niobrara. And as we're selecting these, we want to select these in stratigraphic order. I'm going to use it down to the muddy formation in this example. So that'll cover, all my zones of interest. Now, for the well headers here, I'm going to come in and I'm going to select my well headers. And here we have a couple of just suggested curves here, but I'm actually going to type in a curve. I'm going to type in maturity. And the reason I'm typing that in is because when I look here at my LDB, I wrote a curve here to that database called maturity. And that is what we want to model in this case. And for the property modeling, I recommend using the linear interpolation at the moment. I think that's a good model for distributing these properties. Now, probably the most challenging bit here is we need to, set up the orientation and size of our grid. Now, the best way to do this is you click on this link called Initialize Grid from Files. If you already had a volume, you can just copy the settings from that. If you already had a seismic survey in here, you could copy from your 3D seismic survey. What I'm going to do is I'm actually going to use my my model well headers here, and it'll based on those, it'll pre-populate this. Now, this is a very big area that we're looking at, so I'm actually going to make the inline and cross line spacing 500 by 500 as opposed to 100 feet by 100 feet. And we can see this means we'll have 659 inlines and 729 cross lines. I think that's fine for this area. It's set the origin X and Y, and if we wanted to orient this at an orientation different than 90 degrees, this is where we'll do that. But this data is meant, for what I have in this project, is meant to be looked at, kind of in that north, south, east, west type of view. So a heading of 90 degrees is perfectly fine there. So we're going to hit OK, and we see that now populates this for us. Now here we have a few things. Do we want to have any inline or cross line skips? And do we want to set the elevation? I am going to set the elevation here. Now, actually the defaults, kind of work well for this, but I want the top elevation to be at 0 feet and the bottom to be at minus 10,000, and that's subsea TVD. And I'm going to say we want 501 elevations and 500 stratigraphic depth samples. So that means within this model, we're going to have 500, different different depth samples. So in that case, 10,000 feet, 500 samples, that's one every 20 feet. So that tells us the thickness of the grid cells there. And once we've done that, now we just need to end this with brick output. And I'm going to hit add. And we're going to call this, we're going to name this maturity model, which means we're going to overwrite what I previously made here when I was doing a little bit of testing. And we're going to hit the run button here. Right. Okay, so now our model has finished running here, and we now see that the output maturity model.vol is over here in our file tree. And if we click on this, what it does is it brings up the maturity volume here, and let's just recolor this and apply a different color scale here. And okay, now we can see this model, and let's go through and do a few things here. So first of all, we're going to split our window here, and we are going to add a 3D view where we can see our model, and we're going to set the vertical exaggeration a bit higher on this. We're going to set it at 10x, so now we can see that. And let's go ahead and maybe reposition a few of these inlines and cross line slices here. Now, the first time you go through and do this, it will take a few seconds here for everything to show up, and that's just because of how the caching works here. So as you go through, it will cache that model, and then it'll be much quicker in subsequent runs. What we're going to do is while we're doing this, we're also going to add some of our well headers here. So we're going to add that. We are also going to add our well bores. So we'll select add well bore, and we'll take our model wells, and we'll take our processed deviations. We'll add those in. And now we can see all our penetrations here in the model. And I'm going to split this window one more time. I'm going to drag this down here, and I'm going to add a map so we can see this in map view as well. All right, so there we go. Now we have our 3D model. We have our map, and we have either our inline or our cross line here, so we can come through and choose which one we want to select here. Okay, so that's how we do that. Now, if we wanted to add our grids to this to see some of our grid control, we can just come over here and say add grid. We can choose our structure grid here, say add. And by default, it will add each of the structure grids, so we can see those. If we want to filter that down to a smaller number, we can say selected, and maybe we just choose a subset of those, and we apply that. So now we can see our structure models here. We see our well bores, and we see the property model. And if you're wondering what this purple strip at the bottom here is, this is basically where we below what's below the base of our model. So if you remember, we set a model base of around 10,000 feet. So this is just what's below that in our model. So we didn't have any structural grid control there. All right, so that is our that is how you can construct a 3D property model in Danomics. Just as a reminder, the steps here were we came in here, we picked out our stratigraphic framework, we did our petrophysical interpretation, we ran our structure gridding flow to create a series of structure grids. We also locked in our petrophysical results using our CPI log calc tool, and we wrote that to a log database. And then we ended things here by using our logs to volume tool, where we integrated our structure grids and the zones from that with our log data. We performed that interpolation in here, and we made this model file here, which now we can interact with on the map and in the 3D window view here. All right. Well, I hope that was useful to you. If you have any questions, you can reach out to us at support@danomics.com. Thank you.